Okay, so I'm going to talk about breaking policies and specifications. And the thing is, I basically have one story I'm going to talk about, and then I'm going to talk about a problem I've been identifying, which is not really related to the story, but the idea is that there are similar things in it. After this, there's also a secret. So I'm going to give away a secret. Last year I did a talk here. I also gave away a modification of an old hacking tool. But now this is just an experimental tool to find a specific thing. But I will talk about that later. So my name is Frans Rosén. I've been talking here 2 years. This is the third time. I do a lot of live hacking events. So I actually get invited to events going out and hack a specific company, and then we compete with other hackers. So it's like a game, but you also help a company. Me and Matthias went and competed as Team Sweden, and we won, which was awesome. We crushed Team Belgium so hard. That was our only purpose with the whole trip. So, the idea that I'm going to talk about first is a story about Let's Encrypt and how I killed one of the specifications related to Let's Encrypt. But the story begins with a totally different thing. I was sitting a day in January, 9th of January actually, on the night, I was hacking a company that you might know of called GitLab. GitLab is an open source source code version control system, web-based basically. And they have like a responsible disclosure, you're able to hack them, and I was invited to take a look at the code. The thing was, what I started to look at was not the application itself where you run it locally and you have your own instance. Instead I was looking on the specific cloud service they use, gitlab.com. GitLab.com is a bit different from the app, and the difference was something called GitLab Pages. If you don't know what GitLab Pages is, it's basically like GitHub Pages. It's the same thing. But the cool thing is, basically you're able to develop a website, and you can point your domain to that website, and you can serve, like on docs.example.com, you can serve your documentation, and that documentation is in GitLab, so it's in version control. When I started looking at it, if you saw my two other talks, I'm talking a lot about like subdomain takeover, being able to take over domains because they don't use any domain validation. This was the case for GitLab actually. They did not use any domain validation. That was the first fun trick. So that means that if someone pointed their domain to GitLab, you could go in and say, this is my domain, and you can serve whatever you wanted on it. The way you saw that was basically, the site showed this, a 404, if you went to the actual domain. And I wanted to tell them that. But the thing is, how do you tell them that they're making their customers vulnerable? Like, how do you do that? So I thought, what if I take over a gitlab.com domain with their own tool? That would be pretty cool, right? You're breaking your own site because of your vulnerable system. So I tested to add like blah blah blah.gitlab.com, and that actually worked. They didn't blacklist their own domain. And the thing is, this was like the perfect recipe for me to actually find something. The problem was blah blah blah.gitlab.com didn't result to anything, so I couldn't do anything with just that one. So I had to find a domain that they were using, but was also pointing to GitLab. So the goal was basically find this somewhere. It's supposed to be somewhere. The cool thing was, I didn't have to look that much. Because when I started looking at doc.gitlab.com, that one redirected very properly from HTTP, it redirected to docs.gitlab.com. What they did here was basically realizing, okay, doc is common, but we're going to put them on docs, so we're going to make a redirect. However, if you went with HTTPS, you would see a 404. This was interesting. So I went and took doc.gitlab.com, and it worked. So I had it. I actually had the HTTPS one. So I was like super excited, and that meant that going to HTTPS, it would serve my content instead. So I went there, and no, it didn't work. I got this invalid certificate. I was like, this is so close. And my attack report to them wouldn't be as fun if I go and say to them, yeah, you need to tell people, press advanced, allow, like, you can't do that. So I was like, how can I get a certificate for gitlab.com? The thing is, when you add a domain, you actually get input boxes. Like, upload your domain here, or your certificate here, with your private key, and we will serve that for your domain. Awesome! That is super great. So I was like, okay, so if I put like if you know about Let's Encrypt, Let's Encrypt is like a automated way to get certificates. So I thought to myself, let's approach Let's Encrypt with this purpose. Basically, I can put a file on that domain and validate that Let's Encrypt that I own the website. So if you don't know Let's Encrypt, probably all of you do. It's like free certificates for everybody. They're trying to automate it. It's built by a non-profit organization. And there's like Mozilla and a bunch of organizations funding this internet security group. They have taken out, there's like 10 blessed methods, the way to get a certificate, which is decided on the browser forum, CA browser forum. So they came up with 10. Acme and the Internet Security Group decided that only 3 of them is valid for automation. Acme is like automated management certificate engine, whatever. There's like, the automation can only use these 3 methods. And they are HTTP 01, DNS 01, and TLS SNI 01. So my first project was, I knew how HTTP 01 works. Basically, what it does is, it connects to a specific URL, and it has a challenge in the URL, and if it responds with another challenge in the file, it knows it's going to validate. So I was like, this is perfect. I can actually create a repository called .wellknown in GitLab. I can create a directory called Acme Challenge, and then I can create a file with the first challenge with the content of the second challenge. Everything is awesome, right? But do you remember, HTTP didn't work. Turns out that the HTTP 01 specification was changed from the beginning. In the beginning, it actually tried both port 80 and 443. But there was a lot of vulnerabilities with the actual thing I was mentioning, that HTTPS redirected to a totally different website, because HTTPS was like exotic. So they had to decide that port 80 needs to be open. That's the only way you're going to get the certificate. So couldn't use that one, which was sad. Would have been perfect and very easy way to actually get the certificates, but that didn't work. So next up was DNS 01. DNS 01 means that you need to add a TXT record to your DNS. And if you can't do that, which I couldn't, there's no way to use that one. So then I saw the more interesting one called TLS SNI 01. The interesting part was that it was pretty hard to find, like, you can't go to Let's Encrypt and read like a documentation on how it works, because they wrote like a RFC, like IETF has published a draft on how it is. Nothing is like decided on, almost. Everything is like draft-based. So I had to read those drafts, which was, it's like reading specifications is maybe not something you do on a Friday night. But I did it, and I was chatting with a friend during the time on Slack, and I started reading it, and I'm like, this is super weird. I actually wrote to him, like, this is weird. And I sent him the link, and like, if this is true, this is completely fucked up. And he's like, what? What do you mean? And that's like a common discussion we have. Like, I'm thinking so much about a thing, nobody else is like, what the hell are you doing? So I was trying to explain to him, in simple words, what I read from the specification. I didn't know if this was true, but I tried to like simplify it. So the whole idea is, I want to verify example.com, right? So I say, hello, Mr. Let's Encrypt, or Mrs., I don't know. I want to validate example.com. What happens is that Let's Encrypt says, okay, that's fine, but could you, on the IP address of example.com, serve me a certificate if you ask me about this weird domain called xyz.acme.invalid, and I ask you for that domain, can you serve a certificate that you made yourself? Handwritten certificate. Okay, I can do that. And the thing is, I will now connect to example.com. And I will ask, not for example.com, I will actually ask, hello, server name indication is basically the way to communicate, this is domain I'm interested in. And it will say, can you please serve me a certificate for xyz.acme.invalid? And then I'm stopping like, hey, wait a minute. Don't you have example.com in the discussion? You only connect to the IP, you don't do anything else? No, it's fine, it's fine. Only the acme.invalid. And I'm like, this is really bad. So I was like, okay, so if I want a certificate for one domain, the only thing I need to care about in the validation process is acme.invalid. So I actually took out one of those domains that you need to serve a certificate for, and I tried it in GitLab, sorry. And it said, no, the domain must be between 1 and 63 characters long. And I was like, no, so like, everything just, no, there's no idea to do this. Like, I will not get a certificate, so I'm like, forget GitLab. There was something else here that was pretty interesting. So what I did was, I took this, it's a pretty long domain, right? It's like, I don't know exactly how long it is with acme.invalid, but it's like about 100 characters, right? So I went to two other cloud providers I know of, called Heroku and AWS CloudFront. Both of them are like supporting you to upload your own certificates, which were awesome. So basically, I just pasted in the acme.invalid domain and like to see if they maybe were blacklisting it, because if you can have that domain on them, you can basically connect to them and get a certificate for that invalid acme domain. I added them and it worked. Super interesting. So I was like, I need to test this, and I need to test this in production. Like, I need to validate that this actually works. Now I just added a domain, right? I didn't like actually approach one of the domains. So the target I had was find a cool company that everybody knows of, take one of their domain should point to either Heroku or AWS CloudFront. Because since Let's Encrypt will connect to that, they will actually reach one of these. But then I will add this acme invalid to see if it will actually connect to my own app with the acme invalid with my self-signed certificate, and therefore pass the verification method. So I went to a friend of mine in Canada, working for a big e-commerce company. I will not mention the name, but it's a company that I should not have a certificate for, at all. I went to him and like, I don't know if this is gonna work, but you guys have a specific domain that I could actually test if this works on. Could I issue a certificate for this one? Like, I know this is a weird question, but yeah, sure, you can. Like, yeah, we don't care about that one. And I actually gave him a list, like, these are the ones qualifying for issuing certificates. And he like, yeah, take that one. It's like, nobody cares. Turns out, in the end, people did. So I was like, okay, I have a target. This is Heroku, and my challenge is to serve a certificate for this domain. So what I did was, there's a bunch of open source tools to actually issue certificates using this method. In fact, there were some apps, one called CertBot, built by EF, that only supported this specific method. But I didn't want to use one of these things. I wanted to understand exactly how the flow worked. So I rebuilt one of them, and this was just to make the self-signed certificate myself for the specific domain. So here you can see I'm actually inserting, now it's sun in the way. The only important part is in the sun, no. But I can put all my passwords like diagonal. No, so I put the CN, I put the domain they actually want, which was an interesting thing, because the CN, they don't care about it. Like, you can upload a certificate to CloudFront and Heroku with as many domains as you like. It doesn't matter. What matters then is that you actually, in your app, add the domain. So you can have a certificate, and it kind of makes sense, right? If you have a bunch of sans, subject alternative names, in your certificate that you don't use for Heroku, you still want to upload a certificate that has them as sans, but that shouldn't mean they should be served, right? So the CN here didn't matter. I could write poop there, doesn't matter. But the thing is, I wanted to create this self-signed certificate, and what happened when I ran this one, I actually got out the XYZ, the key for what it wanted me to validate. So I had a certificate, and I added it to my Heroku app, and I went in and I added the .acme.invalid domain for it. And I was waiting, because this doesn't take like seconds, it takes like minutes. And so I was sitting there waiting, and I was like, it would be fun if I'm like doing myself a little teaser or something. So I actually wrote like a bash script that was like an infinite loop, testing every time, and as soon as I see this one, I actually use like say, and it says like, let's see. Yeah. And I was sitting there, and suddenly I like increased the volume on my computer, and suddenly, you broke the internet! And I'm like, holy shit. And the next step I did was basically I just sent one Slack message. I sent the certificate to him. And he answered me, holy fuck. Like, this is not good. And he was like, could I have done something to prevent this from happening? I'm like, yeah, you could stop using Heroku or stop using CloudFront. And I did the same thing on a domain. The same company was also using CloudFront, so I could like use the same company to just approach them. And I saw this, and I'm like, oh, this is okay. And the time I can actually see when I sent the report, it's like, yeah, 5 minutes to 2 a.m. On a Wednesday or something. And I wrote the whole report, like, this is the way. I issued 2 certificates, they're not mine, but I was able to do it because this is how shared hosting works. And they took them 1 hour and 40 minutes. And then they said, yeah, we believe this is actually a valid problem. And then they put up, like, we're shutting this verification method down. And then, due to this message, it turns up on Hacker News, and they're like, what the hell? People are like, what did people find? And they started like discussing all this and like, what did people actually do? What happened here? And I went to bed. I actually went to bed. And this was like before I just like closed the computer and like I tried to sleep. I woke up in the morning and I had 4 mails from Let's Encrypt. And they're like, yeah, we're pushing this today. It's gonna go out in 1 hour. And I'm like, holy shit. Like, what do you want it to say? What do you want to mention your name? I'm like, yeah, sure, do it. And like 15 minutes later, like imagine, like we're talking about a time period of 6 or 7 hours between me reporting and them going out to say that this guy just emails us and yeah, we put it out. Like, we put this black hole, or this verification method in a black hole, and we're gonna see how we're gonna change this. So I was super stressed, because now they went out with all the information, but I really wanted to tell my story of it. So I just hammered down the blog post really fast, like this is how I got these certificates. I also actually went to Heroku and AWS and sent them a report, like this is the information that is going out now. This is a blog post, I will get it out. I don't care, it doesn't matter, the verification method is gone now, so it doesn't matter. And they came back to me and like, oh, you were the Frans they were mentioning. Oh, that kind of makes sense. They also paid money, which was amazing. That was not the intention with reporting to them. So they basically paid me for telling them I'm gonna blog about them. Super weird. The cool thing after this was, Let's Encrypt like fiddle around with, they had like a pretty open discussion on how they were supposed to do in the future with this verification method. The fun part was that they had a new specification called TLS SNI 02 upcoming. But the problem was that that one was just as broken as this one. Like, that one did not solve, it solved another problem, but not this kind of problem. And that one never saw the day of light, because they came out and said, we will sunset both these methods completely. We will never use them. Bye-bye TLS SNI 01 and bye-bye TLS SNI 02. The funny thing was, after this, everybody was waiting for something by Let's Encrypt called wildcard certificates. Wildcard certificates was basically like one of the first reasons a lot of big companies did not use Let's Encrypt in the beginning. Basically, you could not get a star.example.com certificate by Let's Encrypt. And they were announcing to do this in February. And they actually went out. Let's Encrypt have never broken a deadline in their whole existence of 2.5 years, 3 years. Except because of me, obviously. This is the recent deprecation of TLS SNI actually delayed the whole wildcard thing. People were upset. Mostly on Twitter, because companies had decided that we're going to move over to wildcard certs for Let's Encrypt, so they never renewed their existing wildcard certs, which meant that they were like, that's perfect, February is awesome. And then they were even like, no, it's going to be a couple of weeks, we don't know. So I think this explains why I got a bunch of flowers from all the certificate authorities, except Let's Encrypt, when this happens. They're like, thank you, everybody bought wildcard certificates from us. On Twitter, people are like, yes, this would be the first day of the wildcard, but they want this delayed. No ETA. And a friend of mine goes out and like, yeah, that's Frans Rosén, the bearer of bad news. The cool thing is they will probably get a lot better. So that's basically the Let's Encrypt story. There's some fun stories also regarding the other verification methods, but I don't have time to actually cover these in this talk. The next thing I'm going to talk about is something else regarding policies and specifications. I haven't seen that much information being posted about this. So this is a very, I wouldn't say it's unknown, it's just that some people have not been talking about this as much as people should, because this thing is broken as hell, and it's so easy to do wrong. The whole idea with upload policies is basically like, we now use cloud storage instead of actually putting files on your server. It's awesome, but the problem has always been, you need to get the file first. Someone uploads the file, you get the file, but you want to use this external file storage, the S3 buckets on Google Cloud or on Amazon. So you basically get the file and then you transfer it over to S3, which is double the time, right? It takes so much time to, if it's large files, it's a mess. So they come up with a thing where basically they sign a policy, server side, they sign it with their secret key. The policy says what's allowed to be uploaded to this bucket. And what happens is, as soon as you do that, you can upload on client side directly to the bucket. It's awesome. It goes really fast, and you don't need to think about like transferring a file double the time. The problem is it's super easy to do wrong. And the thing is, every time you talk with pen testers and like, what is the feature you start looking at first? Everybody's like, file upload. Always file upload. You upload a shell, you name it .gif, but it's a .NET shell, and everything is good, right? So this is like awesome. We can now isolate our files on a sandbox domain. They can't get to us. And this turns out to actually not be great. So the thing is, an upload policy looks like this. It's basically you're posting directly to one bucket. Works exactly the same way, both with AWS and Google Cloud. In this post request, you have the file content, you have the file name, and you have a base64 encoded policy. The policy looks something like this. It's basically saying like, when should it expire? What's the conditions on the file that you're allowed to upload? So it says, what bucket can you upload this to? And what should the file name start with or contain? Or it's like, what should the file name be? Or you can have this loose thing, like it's at least gonna start with this content. You could also say the access control layer, if it should be publicly read by anybody, or if it should be private, then you need to sign a URL to see it. And you can also like have the content type start with something, and also you can specify the length of the content. This policy, I would say every line of it is vulnerable to some form of broken policy. It's so easy to do wrong. First of all, if you have a start with the key, meaning the file name, and it does not contain a path separator, you can actually host files on the root of the bucket. Sounds like not that bad, right? But the thing is, one of the criteria to install a service worker is that you can put files in the root folder of the domain. Installing a service worker on a sandbox domain is just as bad, because you can have a service worker. Matthias actually made a talk about this on SecT last year. You can actually have a service worker, or the old little brother of service workers called app cache, that if you visit this sandbox domain and you visit my file, I will install a service worker or an app cache in your browser. So anytime you download anything from this sandbox domain, that URL gets sent to me. It's a silent attack to harvest information. And you can actually, service workers are a bit of an upgrade than app cache. App cache, you can say, nah, don't expire at all, basically, which is crazy. Service workers has like a built-in refreshing timeout. However, if you have that worker still on the site and accessible, it can just renew itself. So having files in your root folder of your bucket, don't do it at all. Another issue with this is that if you have starts with and the key, and that key basically contains nothing, or contains the same value for all your users, they can basically replace any other file. So you can modify other people's documents, because that's the policy. You can just break the policy, right? Oh, I can put whatever I want on any file URL on this bucket, which is awesome to attacking, changing images to something completely different, right? Another issue is like the content type. If you have an empty content type, you can of course, like, this should be a text HTML. Kind of makes sense. So you can, depending on the content disposition, you could have basically an XSS. And remember, the XSS is not as bad here as the ability to install a service worker on app cache. The other thing is, you don't need to have an empty content type to bypass it. Because if you provide it first with a valid content type image JPEG, you can provide it with a Z, like image JPEGs, and then a semicolon and text HTML, and it will be served as text HTML. So the whole thing starts with content type basically means whatever content type you want. There's another way to upload data into these buckets. One solution is called AWS STS. And STS is basically an idea. It's moving slowly across. Okay, it says generates temporary credentials client side. That sounds weird. But the whole thing is basically you create the IAM role in your organization, and then with the same thing really. So the policy can make you generate AWS keys. And you can then use those AWS keys to make authenticated requests. And every time we've seen this, they have like S3:* or EC2:*, which is like the worst thing ever. That means that when you generate these tokens with that policy, you're basically getting AWS tokens to take over all their servers. So the whole idea, the whole road thing is basically you're pointing with a token, web identity token, to the STS, Amazon AWS, and in return you get temporary credentials for AWS. And you can use AWS CLI to basically just like, this is in my environment right now, give me all your S3 buckets, and then you just get all the S3 buckets because of this broken policy. We actually reported this as Team Sweden for one of the companies, and they were like, okay, you got all our source code, you can read all the source code, you can replace all our binaries, and all the media people have uploaded is now accessible by you. We actually did a file listing on one of these buckets, and the credentials expired before we could list all the files. So that was pretty interesting. That's a guy with a horse. Anyway, so there's other vulnerable flows. Even Google Cloud is vulnerable to the same thing. The problem is when people are building their own logic upon this thing. So I saw an example like this. Basically, this was pointing to, let's say it was a ticketing system where you could upload images. Just saying, I'm not saying it, but just say that. So you're pointing this to the ticket system, and first your JavaScript said, hello, I want to upload a file called images/test.png. And I told this to the ticketing system, and they sent back like a signed URL. This signed URL basically gave me put access to the file I was asking to upload. But the problem was, as I mentioned, we could overwrite any other file that we had, and the signed URL also allows you to read the document. So that means that even though you had private files, I could say, please get me invoice number 1.pdf. And it would send me a signed link, and I would just take that invoice. And they paid a bunch of money with that, because that was like all their files was in this bucket. So that was like, okay, this is so bad. And they were changing it, basically adding a bunch of prefixes depending on who you log in as. So nobody was sharing the same context of the files. So the whole thing with building your own logic around this is broken almost every time. The goal for me in this investigation mostly has been to reach the root of the bucket. Because if you have a signed link to the root folder of the bucket, you get the file listing. If you get the file listing, you know all the files that's in there, and then you can just make another request to a file you know exists. And then it doesn't matter if they are private, because if you get a signed link, you can just download it anyway. So the goal is to reach the root, or basically reach someone else's file. And I've seen so many scary examples. So example is basically like they had a endpoint called getImage, and you provided a key. And we're back to the 90s, guys, and girls. I could do a path traversal to them. They would normalize the URL and then give me a signed normalized URL for the S3 bucket. So remember, like back in the old days, like please download ... etc password. We're back. This is the same thing again. Basically, I full have access to all the object. I can see all that object, I can list them, and I can just download everything. We're back. Same thing, another service. They were basically asking, like, okay, do you want an S3 URL signature? Cool. The thing was, they were fiddling with the URL. They were taking parts of it, back and forth. So I ended up with this payload, and that gave me the root access of the bucket. The bucket name was example -beta. You can see they have like a double slash there. If you have the double slash before the bucket, it's not counted as a key, and you can get all the info in the bucket, everything. My favorite one was, actually I looked at it, it's 2 years ago. This is not a new issue. Nobody's talking about it, but it's not a new issue. So the whole logic of this site, I see Matthias now like, oh, I know what that site is. But the thing is, basically you said, I want to upload a file. And it said, okay, give me the key. And I gave, slash, it's a cool key, I want that. And basically it created something, and that was super weird. So you basically had a key and an S3 key. So the random key I put was XX11, and then I said the S3 key is slash. It gave back to me, I've created your link now. That meant that going to secure.example.com/files.myrandom key XX11 would redirect me to a signed URL for the root bucket. This was the first time I found this, so I didn't know how bad it was, and I wanted to see how much they had in the bucket. This is an IPO company. They had one bucket. There was the company name .s3 Amazon. It was a bucket name with everything they had in the whole company. Everything was in that bucket. I never got the whole file listing. I have a file that is 2 gigabytes large with just the file names. I kept it for some reason. I don't know. I'm still looking at them and like, you should patch these. These are still public, these files. So this is still very much out there. But yeah, I got the file listing, but I could never see the whole thing. So full access to all the objects. I reported it to a bunch of companies, and they're like, okay, this is actually an issue. This last company I mentioned, that was 2 years ago, and they just like, this is one of the worst things we could ever like see. So they paid me like $15,000 as a bounty and $10,000 as a bonus, just because they were like, this is such a bad thing. But now you're thinking, what happened with GitLab? That is the question, right? I forgot about them. What I did was basically telling them about this domain. They didn't do anything more than just fixing this specific domain. But what happened was, I have a friend called Ed Overflow. And a couple of weeks after the Let's Encrypt thing, he actually publishes a blog post saying, I could actually use GitLab to harvest, I could add any domain I want in the whole world. And anytime they want to use GitLab and use this thing, they will now be served under my control. So he found a way in mass quantity to just add everything to this, which is not the nicest move to show a proof of concept, but that was basically the way it did. So they actually shut the whole GitLab pages down and added domain verification. One of the first companies in the history of this domain verification thing that actually, like, yeah, we're gonna fix this. I thought that I was able to do it by hacking them, as showing that they were vulnerable. No. They were focusing more on their customers, so that was the way. I actually was able to take a full account takeover on GitLab just because I was able to take this domain. I didn't even need to say to them that I couldn't get the certificate issued, because also I didn't want to get the certificate issued because that would look bad. But only by telling them, they were like, okay, this is a critical thing, we should probably fix this. I did this pretty quick, I'm actually done. Thank you very much.
I actually have a question.
No, I have one more thing.
Go for it.
Is the stream off?